Alright, for task 3, I'm gonna first talk about the general idea we have for this problem. So, in this power system analysis course, we learned that to build a Y matrix of the system, we need to know three things about this system: the lines that's in the system, and also the properties of the line. For example, the resistance, the admittance, and also we need to know the buses that the line is connected to, so we know where we can put all the properties of the line in the Y matrix. And to do this, first we need to make a large loop to run through all the lines in the system. And for each line, we first need to know the breakers that's gonna be connected to the line. And for the breakers, we need to know if it's open or closed. If one breaker of the line is open, then we know that this line is actually not connected to the whole system. So we're not gonna add anything of that line to the Y matrix. And if the breakers of both sides of the line they're all closed, we actually need to skip these breakers. We need to do that because we need to check the direct connection of the line and the bus, and we need to skip the breaker that's actually between them. And for the buses, we also need to run through a loop to check all the buses and to find the two buses that's gonna be both sides of the line. And for the property of the line, we need to set all the values to the PU system value. So we need to divide them with the PU values we set before. And for the two other things in the system, the transformer and the shunt capacitors, they're actually very similar to the line. So we use very similar methods. For the transformers, we need to check the buses that's of both sides of the transformer, and then we need to add the properties of the transformer to the Y matrix. But for the shunt capacitor, there's a little difference because the shunt capacitor is actually between one bus and the ground. So we just need to find the one bus that's connected to the shunt capacitor. But there's one thing we need to notice that in the file we found that the shunt capacitor actually has four sections. So we need to multiply that element with 4 in the Y matrix.
Hello, this is Wang Long, and now I will talk about some details in the coding part. In the code, first we need to set the base value, the bus array, and the complex array for Y bus matrix. Here we set the initial values of the Y bus matrix equal to 0, and we need to fill in the bus array with all the buses RDF IDs. After that, we will create a list of lines with their corresponding buses. So now we consider the S-line segment, and we create a loop for it. In the loop, we set a string array list called temp_line to store the data for the S-line segment. First, we put the line's RDF ID in this array list temp_line. And now we need to check all the terminals conducting equipment ID to see whether it matches the line. If they match, we will put the terminal's connectivity node to the array list temp_line. After checking the terminals, we need to check the breakers to see whether there are breakers connected to the line. So like before, we create a list of breakers with their corresponding connectivity nodes. Here we need to check if the line and the breaker have a common connectivity node. If they do, we need to check the status of the breaker to see whether the breaker is closed or open. And here if the breaker is open, the line is out. It means that we do not consider this line in the power system analysis. And here we can see there is get 1 and get 2. It means that one line usually has two connectivity nodes, so we need to check the two nodes one by one. After checking the status of the breaker, we need to know that if the breaker is connected to the line, and also the breaker is closed. We need to skip this breaker, and the function of this part of the code is this. So here, like there are check 3 and check 4, it also means that we need to check the two sides for the line. So if the line's connectivity node matches the breaker's first connectivity node, we set the breaker's second node to the line. After that, we will create a list of buses with their corresponding connectivity nodes. It's the same as before. So if the connectivity nodes of the line and the bus match with each other, we will put that bus in the array list temp line, and in this way we get the list of the first line with its corresponding buses. Okay, and now my teammate will talk about how to calculate Y bus.
Alright, so now we have the information of one line, and also we know that the two buses that's connected to the line. So we know where we can put all the elements of the line into the Y matrix. So the next part, we're gonna calculate the standard PU value of the line. So for the resistance, we're gonna divide them with the Z base value. And for the admittance, we're gonna first multiply them with the Z base value, but then after that, we also have to divide them by into half. And that's because in the power system analysis course, we use the pi model, and in that model we assume that half of the admittance they belongs to one side of the bus, and the other half belongs to the other side of the bus. And after the calculation, we're gonna add all this standard PU value into the information list of the one line we set before. And in the following part, we're gonna add all these elements into the Y matrix. So for the Y matrix, we know that, for example, the Y bus EE, that means the sum of all the properties that's directly connected to between the bus E and all the other buses. And for the Y bus EF and Y bus FE, they are the negative value of the elements that's between the bus E and F. And we have to also know that for the resistance, we have to use the value 1 divided the resistance. But for the admittance, we just use the value of the admittance. So usually when we calculate the Y matrix, we actually run through one bus to another one. But here we got the information of the lines, so we actually calculate two loops. The first loop, we're gonna focus on one side of the line, that's the bus E, and inside the loop, we're gonna focus on the other side of the line, that's the bus F. So after this calculation, we add all the elements of the lines into the Y matrix system.
Okay, besides the S-line segments, we also need to consider the power transformer and the shunt to calculate the Y-bus matrix. But the method is almost the same as before, so we will not talk too much about it. But I think there is something that we need to pay attention to, and we can take a look. For the shunt, there is something we need to know is that when we calculate the per unit value for B and G, we need to multiply it by 4 because the shunt has 4 sections. And also, when we calculate the Y bus matrix for the shunt, we need to know that the shunt is connected to the ground, so it's connected with only one bus. And in this part, we print out the Y bus matrix using a loop. I think that's task 3. That's all. Thank you.